Okay, boys and girls, we are back for day 2 of our e-learning, which will focus on our next math lesson. Last time we talked a lot about the Pythagorean theorem and the Pythagorean relationship between the two legs and the hypotenuse of our triangle. Today we're going to talk a little bit more. We're going to take it a little bit deeper in a conversation. And we're going to start off by talking about something called the Pythagorean threes. And so what they look for in the Pythagorean threes is this concept that you can tell based on the information given to you whether or not a triangle is a right angle triangle, whether it fits into the Pythagorean relationship. So for instance, if I gave you the measurements of 2, 4, and 5, it could be meters, centimeters, it doesn't really matter. Right away, we should be able to identify a couple of things. We should be able to identify that this number right here has to be the hypotenuse because it is the longest of the measurements, and the other two are going to be the legs. So to verify whether or not this is a right angle triangle and whether it fits into the relationship, we have to kind of try out the Pythagorean 3. So we have to input this information. So 2 squared plus 4 squared equals 5 squared. Well, we already know that 5 squared is 25. And now we just have to figure these ones out. So 2 squared is 4 and 4 squared is 16. So we get 20 equals 25. So we know that these three numbers cannot be part of our Pythagorean 3. However, we can try another one and we can see what we can come up with these three numbers. So let's say we have 6, 8, and 10. Again, we know that the largest number is going to be our hypotenuse. The other two numbers are going to be our legs. So if we put that into our Pythagorean theorem, equals 10 squared, we know that this is 100, 6 squared is 36, and 64. So we know that this is an example of a Pythagorean 3. Now, you might be asked eventually to find different types of Pythagorean 3s. So 2, 3, 4 is obviously a really good one. But if you know that 6, 8, 10 is 1, you can also really easily find other Pythagorean 3s very simply. And the way of doing that is just kind of multiplying it. So if I multiply this, all three of these by 2, I'll get a new equation, right? So I'll get 6 times 2 is 12 squared plus 16 squared equals 20 squared. And if I work that out, 12 squared is 144, 16 squared is 256, and 20 squared is 400. 144 and 256 is 400. So again, just by multiplying, once we find one Pythagorean 3, we can find others by just multiplying all three numbers by the same amount. Okay, so that's just kind of an example of coming into what we're going to be talking about today.